I want to go back to the table I looked at in a previous video, and now you do some work with it with some conditional probabilities. So again, you can see the GPA breakdown of these college students along the top. You see their attendance breakdown here. What's the probability a student has a GPA under 2 given that he has skipped many classes? First thing I always like to do with conditionals is just write the statement. Okay, so what's the probability they have a GPA less than 2 given that they have many skipped classes? And now I go to the formula. This is the probability of GPA under 2 and many skipped classes divided by the probability of many skipped classes. Now, because we have a table, there's some reframing you could do right in the table of your sample space. For instance, if you said, well, if I know they have many skipped classes, it's just this row I'm looking at. So it's 80 out of the 110. If you wanted to strictly do it by formula, let me just write down what you would calculate here. GPA under 2 and many skipped classes, so it's these 80 people right here, out of the 1,000 total people. So 80 out of 1,000 divided by the probability of many skipped classes, which was the 110 out of 1,000. So you could see those 1,000s are going to cancel out when you do your calculation anyways. Okay? All right. What is the probability a student has skipped few classes given they have a GPA over 3? So few skipped classes given GPA greater than 3. So by formula, we've got probability of few skipped classes and GPA greater than 3 over probability of GPA greater than 3. So few skipped classes and GPA over 3. So this is this 265 out of 1,000 people. Divided by the probability they have GPA over 3. So that's this 270 out of the 1,000 people. 270, excuse me. Okay. What is the probability a student has a GPA between 2 and 3, given that they have many skipped classes? So probability, let's do it, just 2 to 3, let's write, given many skipped classes. So the formula, probability of 2 to 3 and many skipped classes over the probability of many skipped classes. So the probability of 2 to 3 and many skipped classes, this is the 25 out of 1,000. And the many skipped classes was the 110 out of 1,000. Now, my favorite kind of probability problem deals with using trees. Okay, so I wanted to do a sample here, and then it'll actually lead us to a discussion of the algebra we did on the conditional formula in the previous video. During the 2011 tennis season, Roger Federer made 63% of his serves. When he made his first serve, he won 78% of those points. When he missed his first serve, he won only 57% of the second points. So I read this like a two-step thing, okay? So to begin with, he made 63% of his first serve. So probability he made a serve was 0.63. And if that happened, he won 0.78 of those, meaning he lost 0.22. So here at the end, I have the probability that he made the first serve and won the point. Okay? And down here is he made the first serve and he didn't win. I'm going to write win complement like that, meaning he didn't win. Okay? So the probability he didn't make the first serve, of course, is the remaining 0.37. And of those serves, he won 0.57. So 0.43, he didn't. So probability of first serve complement and win. Probability of first serve complement and win complement. Okay? Now, along those trees, we are going to multiply to calculate the probabilities. And this is from the formula we looked at that was just some algebra on the conditional formula. Okay? So think about it this way. This is the probability he got the first serve. This is the probability he won the point given the first serve. So this is the probability of A and B. So that's why we just multiply. Probability of first serve, probability won the first or won the point given he got the first serve. Okay? So I'm going to multiply this. I'm going to just pause briefly, and I'm going to multiply, along these branches. So 0.63 times 0.78, 0.63. Let me calculate those and fill them in. Okay, so I have put in these numbers now, and I just want to call your attention to a couple of things. First of all, we multiplied along here. We got 0.4914. We multiplied along here. We got 0.1386. I want you to notice that if you added those two together, you would get 0.63 because it's all of the first serve points, won or lost. And same thing down here. If you added these two up, you would get 0.37. If you added all four of the blue numbers up here at the end, you would get 1 because it constitutes the entire sample space. All right, what is the probability that Roger Federer got his first serve in and won the point on a randomly picked point? So that is this number right here, first serve and won. So 0.4914. What's the probability that Roger Federer won a randomly picked point? So now we take the winning point here and the winning point here, and we add them together. 0.4914 plus 0.2109. And we get 0.7023. Okay? Finally, given that he won the point, what is the probability he got his first serve in? So, given that he won the point, so it's going to look like this. What's the probability the first serve was in, given that he won the point? So, by formula, remember we do probability of first and win divided by the probability of win. Okay, so first and win, we already calculated that up top. It was 4914, and the probability that he won a point is our previous answer, 0.7023. So if we calculated that, that would be the probability that he got the first serve in, given that he'd won the point.